Good afternoon and welcome, everybody. Thank you for joining our virtual workshop, Defining Research and Workforce Training Needs for Coastal Resilience. My name's Sharon Ryan, and I'm your facilitator for this afternoon. This workshop is the first of 5 sessions that we're hosting from June 3rd to July 15th as part of the Innovating for Coastal Resilience Summit. The organizing partners for the summit are the Mote Marine Laboratory, North Carolina State University, Florida Agricultural and Mechanical University, and the MIST Center and the Herbert Wortham College of Engineering Innovation Station, Sarasota County at the University of Florida. This session is being recorded today and will be made available on the Summit website in the next day or two. So I'm pleased to be facilitating for you today and delighted to have with me Christine Angelini and Amanda Smith as co-hosts. Christine is the team lead for the summit, and both she and Amanda will be facilitating our chat and Q&A with participants today. So let me invite both of them to say a word or two about themselves. Christine?
Sure. Hello, everyone. As Sharon mentioned, my name is Christine Angelini, and I'm an assistant professor at the University of Florida. Generally, my interests are in coastal ecosystem restoration, and I'm looking forward to getting to know all of you as this summit unfolds. So I sincerely appreciate your time and being here.
Thanks, Christine. Amanda?
Hi, everyone. I'm Amanda Smith. I work with the Nature Conservancy located out of Denver, Colorado, but about to move to Florida at the end of the month. So looking forward to joining you all in the Sunshine State, and I'm happy to help out on this meeting today.
Thank you. So if you haven't done so already, please do go ahead and introduce yourselves in the chat and share what you're expecting to get out of the workshop today. So I'll give you a minute or so to type in some of your answers.
To access the chat, you can use the chat button in the bottom bar of your screen.
If you could just tell us where you're from and what your affiliation is, that would be great. So I see we have a couple of responses already in the chat box. So we have Tracy Fanera, and she's here to learn about water quality. Julie Edwards is interested in increasing her knowledge. And hello to Blake Schaefer as well. And we have Dave Kaplan from the University of Florida, and he's hoping to learn about opportunities for novel sensors. So thank you all for those comments and for participating in the chat. So let's move on. So thank you all for being here today. Our aim with this webinar and all of the sessions that we're hosting in the series is, first of all, to give you an opportunity to participate and learn from each other around a topic of shared interest, in this case, innovations for coastal resilience. And secondly, as thought leaders and experts, we really welcome your help in envisioning an ecosystem of innovation for coastal resilience. So one that's focused on developing new and improved technologies, a workforce development strategy, and partnerships that are driven by a common purpose. So let's get started. Right now, let me walk you through our agenda, and I'm just going to share this with you. Here's our agenda for today. And first thing we'll be doing is, once we finish up with our introductions, we're going to be going into 2 short presentations of about 30 minutes each. And that'll be followed by a question and answer session with the presenters. And during the presentations, please feel free to type questions in the chat or to make reflections on any of the content that you're hearing. And we'll put some of those questions to the speakers later. So let me introduce our first speaker. Our first speaker will be Paul Gader, and he is a professor in computer and information sciences and engineering at the University of Florida. Paul will give us an overview of the summit and summit goals in more depth, and he'll talk about future plans of the organizing partners for accelerating innovations in technology, tools, training, and partnerships in support of healthier, more resilient coastal communities. So next, we'll invite Florida's Chief Science Officer, Thomas Frazer, to walk us through a high-level look at the multifaceted approaches currently being deployed to address Florida's water quality issues. So welcome to you both. So following the talks, we'll have about 10 minutes for you to put some of your questions to the presenters. And again, you can post your questions in the chat during the presentations. If you would like to speak, you can raise your hands to ask a question. To do that, just click on the raise hand button that's down in the middle of your menu. or toolbar at the bottom of the Zoom screen. And I'll call on some of you to ask ask your questions out loud. So after that, we'll be making sure that we have some time to put some questions to you, our audience, and invite you to speak and share your thoughts and ideas on two topics specifically. So one will be around what science and technology advances do you think will have the greatest impact on addressing coastal water quality related hazards in the next three years or so? And then what kinds of skills and competencies will workers of the future need to be part of this innovation ecosystem? So what are the future workforce development needs specifically of industry and agencies related to technologies, data science, and data dissemination? So before we close up for today, we'll ask you to reflect on what your sort of main takeaways from the workshop have been for the day. And at the end, we'll provide a link to a follow-up survey in which you can expand on your thoughts and ideas or respond to comments from other participants, for example, or from the speakers. So we'll also leave the chat open at the end if you'd like to add some more comments there as well. So without further ado, I'd like to hand it over to Paul right now to begin his presentation. Thank you.
So my name is Paul Gader. I'm from the University of Florida. Although I've decided to socially distance myself by placing myself on the moon. So that's where I'm at. I'd like to, thank all of you for participating in this, and I hope this is a productive series of workshops, and I hope that we can help you to achieve your goals. What we're going to talk about is a multi-institutional initiative that we have going here, centered at the University of Florida, but which includes North Carolina State, Mote Marine, and Florida A&M University, and focused on coastal water quality hazards. Okay, so what kind of water quality hazards are we talking about? We're talking about hazardous algae blooms, because red tide, which is a hazardous algae bloom, empties the beaches. We don't like that. We like beaches to be full. Red tide also kills fish. People that like to catch fish don't like that. There are oil spills occasionally, and they wreak all sorts of havoc. Okay, you can have biological contaminants such as E. coli and sea level rise. Now, these are all kind of interrelated, but the point is that we want to create a general capability to respond to all these types of coastal water quality hazards. And many of you are invited because you are working hard to address these challenges. And I just kind of want to go through and show everybody who the participants are. So we have local, state, and federal government. You can see the wide range of groups here. You got Sea Grant, USGS, Army Corps of Engineers, EPA, NOAA, NASA, Florida Department of Education, Environmental Protection, Florida Fish and Wildlife, and GTM. So all of these are here. And there's one over in the corner, but I can't see it because of my Zoom. Florida Health, Department of Health. Okay. All right. We have some non-governmental organizations here as well. The Nature Conservancy, Socorro, who does a lot of work in this area, Gulf of Mexico, Coastal Ocean Observing Systems, and of course Mote, who's on our team. So they are all NGOs. And now we have lots of technology companies. We have engineering firms such as Harris, Northrop Grumman, and so on. And I can't begin to go through all of these companies, but we have sensing companies, we have data analytics companies, and so on. A lot of representation here today. Okay, we also have tourism and community action groups. So Sarasota, of course, is where we're going to be focusing our research initially because of the Mote Marine Lab and because of the high prevalence of hazardous algae blooms there. So they're participating very strongly. And also the University of Florida has the Innovation Station, which has played a major role in putting this webinar series together. And we have other groups as well, community action groups. And then of course we have the academic institutions, and our partners, North Carolina State, Florida A&M. And I also want to point out that at the University of Florida, we have the College of Health and Human Performance, where they're looking at tourism issues. We have IFAS, which contains a Sea grant. Okay, IFAS stands for the Institute of Food and Agricultural Sciences. We also have the College of Medicine, because I'll talk about that in a little bit. And we have the College of Public Health and Health Professions. So public health and the environment are tightly related, and that's one of the things we want to look at very strongly. Okay, currently the kind of state is all of these different types of groups are not necessarily well connected. So if they were a machine with a bunch of gears, it wouldn't work. The gears would not mesh. Okay, so what are some of the problems? Well, some of the problems are that there are communication gaps and silos, as we like to refer to them at the university. So sometimes you have potentially valuable contributors who aren't even aware of what they can do to help solve the problem. And often our information sharing is unidirectional. We may go out and collect data, we don't tell you about it. Somebody else collects the data, they don't tell us about it. Okay, so that is also related to the data sharing. We could share data much more. There are lots of ways to support sharing of data better. And also, one of the big problems with sharing data in databases, of course, are the variety of data formats. So standardization of data format is a big thing. Also, software, things which we can use to process data from all these different sensors. If we come up with good pieces of software, we'd like to be able to have a repository to make it available to everybody. Okay, so what we want to do then, our vision is to create this thing called the Engineering Center for Coastal Solutions, which we'll refer to as ECCS. Okay, and here's what we want. We want to be able to help connect all of these different groups into a kind of a well-oiled machine. Okay, that's what we have. And so all the gears are clicking together, and we can help provide solutions to the problems that I just mentioned. Okay, so what's our overarching goal? So what we want to do is we want to be collaborative. We want to work with people who are working on this problem, and of course, many of us already do. And our collaborations will involve both research and education, and I should say technology transfer. So that's part of what can happen through the innovation station and so on. Okay, we want to help produce coastal forecasts and ways for mitigating some of these hazards that will improve the life and economic health of Florida and other coastal states. That's what we want to do, and we want to help you. We do not want to reinvent the wheel. So that's why we're seeking a lot of input. Okay, so the general framework is as follows. We think we're going to put out sensors. Other people have sensors. There's online databases of information. We want to combine those using data science and AI. And by the way, this is a very simplified diagram. I have a much more complicated diagram that I'm not allowed to show in this context. But so, if it looks a little bit like there's not enough there, that's why. But we process the data from sensors. We have Internet of Things tying the sensors together. We have collaborative sensors that are looking at blooms, things like that. We want to take all that information and feed it into hazard models. We want our hazard models to include both biology and physics, so that they can really predict where these things are going to go. And the information then will go out to mitigation, forecast, geovisualization. Every county that I know of has a has a GIS system, Geographic Information System. We would like to put out data in that format. Okay. So what are our goals for today? What we'd like to do is engage those currently addressing these challenges. We want to know how we can design our research and education programs to help to provide the best possible support to these things. Okay. And we want to identify what is the state of the art. What are the tools and the data sets we can leverage now? And there are lots of them out there. Okay. We want to see what gaps are in some of these existing resources. And we want to form partnerships, which is one of the reasons why we invited you all here. We want to partner with you and we want to help you. Okay. And we also want to know, what are your workforce training needs? What kind of education do you want future employees to have? Okay. So that's what we want to do. Okay. So the series at a glance is kind of interesting. So what you see here is that little diagram up in the corner. And the thing that I want to emphasize here is that the water quality needs drive our technology. So we are creating what's called an engineering research center. So it's an engineering center, but it's not looking at technology for the sake of technology. It's looking at technology to support the needs of society in dealing with these water quality hazards along the coast. That's our goal. And we want to sense the kind of information. We want to create the kind of technology developments that will support that goal. So the first seminar is today. It's defining the workforce and training needs. Okay, so that's what we're talking about, kind of an overview. The next one is enhancing community resilience through effective data communications. So that's really kind of the output layer. So we're starting out with the output layer because those are the people that define what they need for the problem solution. Then we're going to start looking at sensors, and seeing what kind of sensors do we need, what kind of sensors are out there, how can we deploy these sensors, what are the sensor platforms, and so on. Then we want to look at leveraging AI, machine learning, signal and image processing, all of those kinds of things to help improve and innovate in the area of coastal resilience. And then the last workshop will be summary of the research priorities and partnerships that, those things that we learned about here today and those people that would like to partner with us. Okay, there are a couple of things that are not going to be part of the seminar series, but are very important, and I would be very happy to talk about these in detail with people who are interested. One is a data science and public health component. So we have an organization here at the University of Florida called One Florida. And you can see on the right all these little dots. These are all healthcare institutions, and they give all of their data to the University of Florida Medical School, and they have a huge database of healthcare records. And what we want to do is take databases that are out there. For example, the state of Florida has hazardous algae bloom databases, and combine those with the health record databases and try to understand what are the long-term effects of some of these environmental hazards on human health. And I think that's a very important problem. We all kind of know the short-term effects of a lot of them, but we don't necessarily know about the long-term effects. And another thing we're talking about is, we really want to focus on using natural systems to mitigate these problems. Okay, so what you see there is oyster reefs. So oysters do a great job, I'm told, in filtering all sorts of things out. And we want to look at things like that, coastal marshes, how, we have people that are modeling the flow of nutrients from the land to the coast, and we have people that are modeling the coast. And what are the natural processes that we can use to mitigate the problems caused by things flowing from the land into the water along the coast. And with that, I'd like to introduce our next speaker, Dr. Tom Frazer, who is now the Chief Science Officer for the state of Florida. And we're very happy that he has been appointed to that office. He's also a professor here in Fisheries and Aquatic Sciences at the University of Florida, and he can give a great perspective of what's going on in the state right now.
I just want to say thanks to everybody, Paul and Christine, Sharon, and Amanda for putting this all together, allowing me to come and chat with you. And it's really nice to hear about the effort that's going on. And when I first talked to Christine about this, we were thinking about, wow, what can I provide here in 15 minutes? And there's a lot, the challenges in Florida with regard to the environment are many, right? So we're a water state, so there's no shortages of environmental related challenges there. But I'm going to go ahead and say that it's clear, at least from a state's perspective, that there's a focus on water quality. And I mean, there, waters throughout the state are clearly degraded. I think the governor and his administration recognized that. That was a key part of his campaign message, right? And so when he actually took office, one of the first things he did was issue an executive order that created my position, for example, but he also outlined a plan that, um, you know, allowed for an investment, greater investment in addressing the water quality issues that we are experiencing. And what was, I'm not going to say necessarily nice about that, but it was important is that there was a recognition about the quality of our environment and our economy. And I think that had been severely lacking for many years. And at the time of in late 2018, I guess, um, we were reeling from the effects of toxic blue-green algae blooms, red tides, and all kinds of things, particularly in South Florida. And so, again, he campaigned on that promise to deal with the issue, and I think that's been a large part of my responsibility moving forward. So I want to kind of walk through where our focus has been, some of the things that we've accomplished, where I think we're going. And I didn't want this to be a really long talk, again, because it's broad, but I'll hit some high points. I want to give people an opportunity to ask some questions. So again, one of the things that the governor did, he issued an executive order that laid out a proposal for $625 million to deal with some of these water quality issues. And on the top of that list was more than $400 million for Everglades restoration things. There was $100 million for springs restoration. For those of you who are in Gainesville or in close proximity, know that we are kind of the springs mecca of the world, and so it's an important natural resource. It's part of our cultural heritage, but they're under stress, right? And so that's important as well. We had more than $50 million for targeting water quality improvements. That was primarily aimed at TMDL projects. Again, so the regulatory agency in the state identifies waters that are impaired. To address those impairments, they go through a TMDL process and develop restoration plans. So $50 million specifically to deal with those impaired waters. What was nice also is that there were $40 million allocated for alternative water supplies, and that had been largely zeroed out of the budget for more than a decade or so. And so it's not all about water quality. It's about kind of that nexus between water quantity and water quality. And as we talk a little bit further, I think we'll find that there's a lot of opportunity, to kind of deal with both of those issues at the same time. And then finally, there was $25 million to combat the harmful algal blooms that Paul talked about, both blue-green algae and red tide. And so I'll talk specifically about some of those issues moving forward here. So with regard to Everglades restoration, again, it's certainly an important part of our efforts right now, but it's not the only thing, right? We've got harmful algal blooms, there's springs protection, climate change and sea level rise, and coastal resilience are all huge issues, right? And they play a huge role in where we're going and where we're investing our resources. But um, oftentimes we just talk about the problems and we don't talk about some of the successes. And I think we've had some really good ones over the last year, particularly with regard to Everglades restoration. Everybody has come to the realization in order to effectively restore the South Florida ecosystem and kind of prevent the damaging discharges to the northern estuaries, either on the west coast or the east coast, that we have to provide ample storage and treatment of that water. We need to be able to capture it, store it, and convey it so the water gets to the right places at the right time. That's not a trivial effort. It's a multi-billion-dollar effort that's going to take decades to achieve. But I think we've got some really big pieces um, you know, into the picture right now. We're close to finishing them. And I'll go through the highlights. We are about to complete some storage on both the east and west of Lake Okeechobee. This coming year, we'll finish the rehabilitations in partnership with the Army Corps of Engineers on the Herbert Hoover Dike, which is, essentially the protective structure around Lake Okeechobee. We've got dollars to finish renovations of the Tamiami Trail so we can allow more water to move south into Everglades National Park and ultimately into Florida Bay. And so, we have further authorization to create storage north of the lake, and we started the Everglades Agricultural Area Reservoir. So all of these things are cool. I think actually they're a long time coming. Just to give you an idea of some of the scale of these projects. In 2022, I think we're going to be completed with the construction of the C44 reservoir and SDA. Again, so water storage and kind of treatment go hand in hand. This is going to improve the situation east of Lake Okeechobee going into the St. Lucie area. So I'm happy to see that. On the west coast, again, probably construction's ongoing for the C43 reservoir. Again, several 100,000 acre-feet of water in that particular reservoir. That will be completed in 2022, early 2023. Again, I mentioned renovations on the Herbert Hoover Dike. Those are anticipated to be largely done in 2022, if not completely done. Again, I'm showing many of these pictures because I don't think people really appreciate the scale of some of these activities and the engineering that's involved here, right? I mean, that the I mean, this project costs about $1.8 billion, right? And it's taken many, many years to do that. What they're doing is putting down kind of a retaining wall in the dike here, and those concrete slabs that are going in there, they're tens of feet down into to the ground there, but they cover miles and miles and miles of a dike, So this project's a long time coming, and it's going to be really great to see it completed, and it will coincide with the new regulation schedule for the lake, which is going to be completed in 2023. So all of those things moving forward are good. Let me see here. A lot of you probably heard about the Tamiami Trail as well. A large part of that $400 million that we got last year was matched with the Department of Transportation to elevate the Tamiami Trail so that we could convey more water south towards the park and into Florida Bay. When that's completed here in the very near future, we started construction on that. There was a notice of intent that people should be aware of. We're going to ultimately move 80 billion gallons of water into an area that hasn't received that type of flow in quite a long time. So for those who are strong proponents of Everglades restoration, this is a very welcome picture, one that people, and expected to see in quite a while. And then finally, the EA reservoir, the Water Management District has issued the permits or authorized the permit for the construction of this reservoir. And so we're making good progress on that as well. So then springs protection is another thing that we've worked on in large part over this last year to try to make sure that we had projects that were awarded and ultimately implemented that not only focus on water quality issues in the basins, right? But also on water quantity issues. And I saw that David Kaplan is in the audience here, but it's because of work like David's and others, folks that are on this call, that we recognize that it's not just all nutrients, right? It's restoration of flow as well. And so part of my effort is try to make things a little bit porous, right? Understand what the regulatory needs are, but also understand what science is out there so we can use that science to make better decisions moving forward. And so that's why I was really happy to be on this call today. A lot of your guys' interest obviously is in coastal resilience. And one of the things that came out in the governor's executive order was the creation of an Office of Coastal Resilience and Protection. And that office is responsible for about 4.5 million acres of submerged lands, right? So it's not a trivial undertaking. There's a lot of responsibility there. And last year, that office delivered, close to $6 million in resilience-related projects, and I expect that they'll have a similar amount of investment moving forward, not only this year but in the years ahead. So, and again, it's a good opportunity to work with folks in the academia, the private sector, and the nonprofit world, really to think about, how do we leverage those dollars to do innovative and pretty cool things. So, so this is where I spent most of my time. And again, what drove all of this was the fact that we had these blue-green algae outbreaks in Lake Okeechobee and red tide at the same time. The release of algae-laden water from Lake Okeechobee, both on the East Coast and the West Coast, resulted in a tremendous impacts, economic impacts, environmental impacts, human health impacts. And it's clear that we need to get this problem under control. And so to deal with that, one of the things that we did is we created a blue-green algae task force. There's 5 folks on that task force. Jim Sullivan, who's the director of Harbor Branch Oceanographic Institution, Val Paul, who's at the Smithsonian. And let me see, there's Mike Parsons, who's at Florida Gulf Coast. Wendy Graham, who's here at the University of Florida. She's the director of the Water Institute, and Evelyn Geiser, who's an endowed chair at FIU and has a tremendous background in ecology, particularly in the South Florida ecosystem. So it's a good group of people. We spent most of this last year working on identifying problem areas, particularly sources of nutrient pollution, and how we might deal with those. And in October, the group actually released a series of recommendations or a consensus document that allowed for the development of what is known as the Clean Waterways Act, Senate Bill 712, and that's sitting on the governor's desk. But I thought it was a fairly comprehensive piece of legislation that allowed us to move forward and address some of these things that have been recognized as problems for a really long time. And they hit on all sectors. We recognize that everybody's part of the problem. Agriculture is part of the problem. Urban areas are part of the problem. So we've got recommendations with regard to agricultural best management practices, recommendations with regard to wastewater facilities and stormwater systems, recommendations that have to do with septic to sewer conversions and septic more generally. So all of those things I thought were very important, and I thought I would not spend too much time on those, but also point out that the task force recognize that we need a greater investment in our water quality monitoring program, and that needs to be science driven. You know, we don't have enough resources necessarily to monitor everything in the world, so we have to go about it in a pretty thoughtful, strategic way. And I think that involves a lot of discussion with people that are engaged in that arena. And a lot of those folks, again, are on this call. They're from engineering firms, they're from academia, they're from local governments, etc. But one of the things that is probably most important was the recommendations as they relate to innovative technologies. And there continues to be a recognition that we need to develop these innovative technologies, and we have a grant program that allows us to do that. Last year, there was $10 million specifically for technologies that were related to blue-green algae. There are additional dollars that are related to red tide. But what we've traditionally used those monies for is for cleanup and mitigation. And but I think there's a recognition that our investment in technology needs to be much greater than that. We're interested in technologies that allow us to be more proactive, so preventive types of technologies. Um, Paul pointed out that there's a need to deal with or invest in sensor development, analytics. So all of those things are on the table, and those things do come through my office, certainly up in Tallahassee. And it's important to me to make sure that we have a diverse portfolio of investments in the innovative tech arena. So that'll be something to talk about, I think, here on this call today. And I think with that, I'm just going to leave it because there's, a lot to talk about, and you guys probably have a lot of questions. So I'll happy to entertain anything that's on your mind.
Thank you, Tom, very much, and thank you, Paul, as well. While you're just unsharing your document there, we'll get some questions to both of you. So we did have a number of questions in the chat, and I'll start with one for you, Tom, and this is asking, what was the previous land use status of the sites where water storage is being constructed?
Yeah, so those are good questions. I'll kind of work backwards, right? So the one that's receiving or the newest is the EAA reservoir, right? And that was obviously largely agriculture, and the land for that particular reservoir was obtained through a negotiation or agreement with the agricultural parties, sugar in particular, right? So that was one. I'm not for sure what the earlier land use was for the C44 reservoir in STA, but again, the land west of the lake for the C43 reservoir was in large part kind of agricultural undeveloped lands. So um, I, I'm not sure what's motivating the question, but I suspect there's an underlying motivation, and I'll preempt that a little bit by saying that, one of the things I didn't mention is that we have a pretty aggressive land purchasing program in the state, and last year we were fortunate to receive $100 million for that program. I'm not sure what the budget will bring this year, but, we're hopeful again that we can purchase other lands through the Florida Forever process. But what's really good about those purchases, and I think that a lot of people don't recognize, is that there's often a water quality element to them, right? They're purchased in strategic places. They're wetlands oftentimes, or they're recharge areas and things of that nature. So um, you know the past status of land, the ecological services that various land parcels provide are all part of the things that go into the consideration of all of our activities.
Okay, great. Thank you so much. And I have a question for Paul as well. Can you comment on where you think technological advances can help us achieve these environmental water quality goals? And the second part of that is, are we limited by data, insights, money, or will?
Well, I think we need much better, cheaper and mobile sensor networks so that we can do a lot more monitoring. Tom had referred to that before. We need to do a lot of water quality monitoring. So, having the ability to have mobile sensor networks out there to, see what's going on and to be able to understand the processes that cause these things to go where they go is very important. So all of those sensors give information to the models, and the models, of course, are the things that produce the feedback. So the sensors are not only good for operational systems, but they're also useful for model validation. So making sure that the models are able to predict correctly, those kinds of things. And of course, data science, AI, those kinds of things. There's a lot of going on there, and the University of Florida is very active in applications of AI to systems. So, but that's very good. Data science tools, those things are good, and specifically those that are focused on combining, I would say, environmental databases with public health.
Great. Thank you so much. Just one last question for you, Tom, and then we'll move on to the interactive session. So from Britta Jessen, is there any discussion about elevating Tamiami Trail farther west of Tamiami?
Yeah, so so they've done phase 1 and they're moving into phase 2 right now, which is the western part of that roadway. So they'll begin construction on that soon. It's again, as I said, they've issued a notice of intent to move forward on that. So there's typically a 30-day public comment period associated with those types of things, and then I would expect construction to move on. If I can go back real quick, because I only get you guys for a few minutes, and I think there's a lot of important things to say. And Paul made a good point, about water quality monitoring and the need for mobile sensors, but those sensors oftentimes generate lots of data, and then you need appropriate analytics and training to deal with that. And I really can't stress how important that is to recognize that, because we have a lot of remotely deployed instrumentation that generates tons and tons of data that has never seen the light of day. And the reason is because we don't have the personnel to process it or the bandwidth to do that. And so, it's really cool working in an academic world and generating stuff, but at the end of the day, you have to deal with it. And so I spend a lot of time trying to make those types of connections, and I think they're super, super important when you embark upon these types of projects, to think about who the end users might be and what the limitations might be on their end. So, anyways.
Great, thank you. I think that's a great segue into our next component here in the session. So we'd like to pose 2 questions now to our participants, because we have so much expertise and thought leadership out there. And I'm just going to share a document with you again so I can show you those questions. And Christine, if you wouldn't mind reading out our questions for our participants so they can have a chance to think about.
Sure thing. So hopefully you're all have your sort of brains cued to this general topic, and now it's your turn to contribute, as Sharon said. So we're curious, from where you sit in whatever industry or profession that you're in, what science or technology advances you personally think or predict will have the greatest impact on addressing coastal water quality hazards in the next 3 years. So perhaps not tomorrow, but what are these innovations in either fundamental science or in technologies do you think are the place to invest our money in the coming years? So we look forward to hearing some of your answers in the chat. So please be as broad thinking and really sort of share your expertise in this area.
Also, please, you have a few minutes to respond in the chat, but please raise your hand if you'd like to speak and say a few words. That would be really great. And if the rest of you would like to keep typing in the chat in the meantime, that's great. Feel free to do so. Once we get some thoughts coming up, or if someone would like to speak, please just raise your hand and we can unmute you, and would love to hear your thoughts. We could also go back quickly to a couple of more questions because we did get a lot of questions in our chat. One question we had from Andrew was that there are clearly some water quality needs here in Florida to be addressed by the ECCS program that you're proposing. How will ECCS interface and have relevance at the regional and even national level? Paul, would you like to offer some thoughts on that?
Sure, I would. That's part of what we're trying to do here. Is we have a lot of partners, so we intend to write a National Science Foundation proposal for this, which is a fairly large proposal, and we want partners from government agencies at all levels. So we've talked to people from NOAA, we've talked to several people from the state of Florida, and 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 we've invited you all here. And I think we need to know what you need, and we need to work with you to understand what you have and what you need. And so, it's by forming partnerships. We have the Army Corps of Engineers right now. We have NOAA, things like that.
Great. Okay, thanks. We also have a comment from David.
Hi, everyone. Yeah, I just wanted to say hi and encourage everyone to shake off their mute buttons and participate with your ideas and suggestions. I think Paul DiGiacomo, you and I agree. I think this idea of being able to get remote sensing data validated in the field potentially can really open up our capacity to be monitoring in more places at more times. We need to do the field work. And I really like maybe the invitation from Dr. Frazer to go and uncover all that data that hasn't seen the light of day and use that to improve this remote sensing. I think that's going to be the biggest advance, at least over the next 3 years. So thanks, everyone, and thanks for attending.
Great. Thank you so much. So we did have a comment from Arnaldo. In terms of technology, we need to be able to measure nutrients at high spatial and temporal resolutions. Let's see. And someone else, Kevin Main, I really like the idea of utilizing cultured natural filters, cultured plants and animals to clean up our coastal ecosystem, and that this approach has been very effective in other parts of the world. So, Christine, how about we go to our second question?
Sure thing. So our second question for all of you, and this is something that we're particularly interested in regards to the organizing team, because our mission in both MOAT and these university institutions that are supporting this event, and what we can do with regards to educating the workforce. And so we're curious what you think the skills and competencies workers of our future will need to be a part of this innovation ecosystem that we've been discussing today. And then specifically, what are the future workforce development needs of either your industry or government agency related to technologies, data science, and data dissemination? So these kind of top areas we've been talking about in the discussion today. What's your dream workforce of the future, essentially? And I just wanted to give a quick shout out to some of the answers to the first sort of question in case it has any relevance to your answers to the second. But Betsy suggested that forecasting to support future mitigation activities and understand where investment should be made is really on the forefront of our research needs. And Jessica McIntosh highlighted a need for us to better understand the sources of the nutrients that are entering our coastal waters and therefore more sophisticated technologies related to nutrient source tracking.
Great, thanks, Christine. And we also had a comment from Tracy around programming for question 2. So the need for more programming, sensor technologies, and data analysis. So those are some of the skills that are being anticipated in the future as needed by entities that are involved in this work.
Can I respond to that quickly?
Sure.
So one thing I'd like to say is that this year I just finished a committee and I put together a master's degree in applied data science. So this is a master's degree that's designed for people who are not computer scientists, who are not computer engineers, but want to use data science to solve problems in their areas. And it's a degree program that allows you to focus in different concentration areas, and one of them could be coastal water quality. So we could work with the state or other interested institutions to come up with data sets and problems that people can work on en route to their master's degree in this field.
Great, thank you. Christine, I see we have some more comments coming in as well. So around programming languages, Python increasingly is important. Also understanding of cloud services coupled with the AI approaches. So it looks like there's lots of great ideas that people have been thinking about. I'm mindful of our time. We have a couple of minutes left as we head towards our closing. And I just wanted to ask, does anybody else have anything they wanted to say or put in the chat box? Please just raise your hand and we'll get to you. I encourage you to read other people's ideas that are coming up in the chat box as well, and to listen if someone would like to speak. So just as we head towards the end here, we'd just like to ask everyone to reflect a little bit on the presentations and on the content and on the sharing for today. And let us know if there's kind of one main takeaway that you've gotten from the workshop this afternoon. We'd really appreciate your reflections and thoughts on that. So you can go ahead and type in the chat box. If anybody wants to speak, please feel free again to raise your hand. So I'll just would like to thank you all for joining us today, and we hope that you'll attend some of our other upcoming workshops in the next couple of weeks. So in next week's session, for example, we'll be exploring information platforms and how to effectively communicate data on coastal water quality to end users. So that means people in tourism, on the business side of things, or government agencies as well. And we'll be doing deeper dives into all these topics through breakout groups, and each breakout group will have a discussion convener, so you'll be able to dive into a number of questions, focus questions around these topics that Paul mentioned during his presentation. So you can click on the Summit website, which Amanda has posted or will post in the chat box as well if you'd like more information on registration. We're also posting right now a survey, a link to a survey, and we'd love it if you'd go to the survey and just complete it now, if possible, if you have a few minutes towards the end here. And we'll also be leaving the chat open as well. So continue to share your thoughts and talk to each other, chat with each other. You'll have a little more time at the end of the webinar. So that's a great place to expand on answers, share more ideas. Same with the survey. Any kind of input or insights, things that we haven't covered, stakeholders that we haven't included. It would be wonderful to hear those perspectives from you, and that way we can follow up for the next set of sessions and make sure that we're inclusive of everybody and we're covering the topics that are most important to you. So with that, I would like to say thank you to Christine and Amanda for being wonderful co-hosts and facilitating all those conversations that have been going on. And also to Paul and Tom for taking the time today to come and speak to us, and for just being very thorough. And we appreciate that. And so to all of you for being involved and for coming and participating, for listening and sharing. We really appreciate that. And we hope to see you at our next workshop next week on Thursday, June 11th at 1:30 p.m. And in the meantime, stay safe, everyone, and stay healthy.